Hi guys, and welcome back to Pen and Pencil Academy. In this video we are going to go through Pythagoras' theorem, just a quick recap of what the formula is, and then we're going to go through some exam questions, some tricky exam questions with given context, instead of just giving a triangle and asking you to find x, y or z, whatever they give you. So in part 1 of this video we looked at the Pythagoras theorem, and we found a formula, or you were given a formula, and that formula is a squared plus b squared equals to c squared. So we know this from part 1 of this video. Now we looked at two questions, and in the two questions the question gave us length A and length B, and we were told to find length C. And those are quite simple versions of questions that you can be given regarding Pythagoras' theorem. Now, a trickier question looks like this. So here we have a question, and as you may have noticed, it's not a triangle. So they've given us a question where they say that the diagram shows a sweet box with a radius of 0.1 meters, I hope you can see that, and a height of 0.6 meters. So the radius is 0.1 meters and the height is 0.6 meters. Now it says a fudge sweet is 0.4 meters long. It cannot be bent, so you cannot bend it and put it into this box. It has to be put in with its full length. Will it fit into the box? And it says give a reason for your answer. So first of all, we can redraw out this diagram. So now we've got a bigger version of what they've given us. And if we look at it, we can see that if we extend this radius and make it into the diameter, the whole box is actually 0.2 meters this way. So the diameter is 0.2 meters. Now we have a sweet which is 0.6 meters long. That means if the diameter is 0.2 meters, we cannot put in this fudge sweet this way. That means that we're going to have to try another way. And usually when they give you questions like this, they could make this into a swimming pool. They could give you lots and lots of different scenarios with the same shape here. And in general, what we need to do is think about how we can fit this sweet in diagonally. So this way. Now, this looks similar to a triangle that we could draw. And this triangle could look like this. So we've got 0.6 meters here, and we've got 0.2 meters here. And this we can label C, or we can label X, so any unknown components, we can call it anything. And that is what we need to find out. Now, if this value is larger than 0.4 meters, it means that this sweet will fit into the box. If the value of C is lower than 0.4 meters, that means that the fudge sweet cannot fit into the box. So just keep that in mind before you start working out. So now that we've got the triangle, or a triangle, and we see that we've been given two lengths, and it's a right angle triangle, we know that we can use Pythagoras' theorem. And it's a squared plus b squared equals to c squared. Now we've labelled one side, we labelled one length, we need to label the other two as well. So if we label this a and b, all we have to do is substitute these values back into the equation. So we would have 0.2 squared plus 0.6 squared equals to c squared. So let's work that out with our calculators. Remember, and keep this in mind, that sometimes this may be a non-calculated paper where they'll give you whole numbers. So numbers that you can work with. For example, 4, 3, 5. any like simple numbers that you know your times tables for, so it's easy to work with without a calculator. Here you'll probably need a calculator, and c squared in this case is equal to 0.4. Yeah, so to get the value of c, all we have to do is square root that 0.4. Now when you put that into your calculator, you're going to get quite a long decimal, and it would be 0.632455532. But we don't really want to have that. We don't want a very long decimal. You could write it all out, because it's only asking you if the suite fits or not. So we can write the whole thing underneath. But just to make our lives easier, we could put it into 2 significant figures or 3 significant figures, because it will be easier to compare. So if we say this is 0.6 meters, we just put it to 1 significant figure, because this is also 1 significant figure. We can see that the value of c is 0.6 meters. Now for those of you who are looking at this over here, getting confused, it just means therefore. Yeah? So what we need to know, what we can conclude from this, is that because 0.6 is larger than 0.4, the fudge suite can fit into the box. Now, if you're a little bit confused about why I put 0.6 meters here, remember that you can just work with this whole number, this whole decimal here. You can just work with this and compare it to 0.4. But just to make your life easier, you can condense it down into 2 significant figures. This is just 1 significant figure. So this is to 1 significant figure. And it's just so that it's easier to look at the numbers and compare which one is larger and which one is smaller. Because this decimal here looks very different to that decimal. So it's just for you to be able to work out more easily. And if you can't, if you don't have enough time in the exam, do not worry. Just look at the first part of the decimal, or maybe don't write all of them, all of the numbers in the decimal. Maybe just write the first 3 or 4. So the answer to that question would be, yes, the suite does fit into the box because it's smaller than the diagonal length of the box. So that's what we would write as our reason for our answer. So that is one of the questions I wanted to go through. And it's just because they're not giving you this triangle at the very beginning. You have to work out what the triangle will look like for you to work with, and for you to use this formula up here. So looking at it right at the beginning, you might have been very overwhelmed because of the question. Maybe you've never seen a question like that before, if you've only been working with questions like this, where they already give you the triangle. It's very simple. All you have to do is read the question, see what they're asking you, and see if you can find a solution. Now that sounds quite difficult, but if we look at here, so it's said that we're trying to fit a suite in. And the only way we can do it, we can either put it this way, so horizontally, like I've drawn it here, or we can do it diagonally. So those are the 2 options. So give yourself different options when you're working with these types of questions. So that was the first question. Now let's do another question. So here is our second question. Now it says a rope is tied to a pole of height 20 meters. The other end is tied 4.9 meters from the bottom of the pole. What is the length of the rope? Now the last part of this question that I forgot to add is the most key piece of information that you need to remember when giving your answer. And it says give your answer to 3 significant figures. So first of all, what we need to do is we need to read the question. And then we need to find a solution. But we need to also give ourselves different options of how we would work through the question. So we know that there's a rope and it's tied to a pole. So we know we can just, if we draw it here, we have a pole here. Very simple drawing. And we know that this pole is 20 meters. But we also know that the other end so we have a rope as well, and it's tied from here down here, because it's tied 4.9 meters from the bottom of the pole. So if this is the bottom of the pole and it's tied here, this length here would be 4.9 meters. And what's the question asking us to do? Find out the length of the rope. Now we're getting somewhere. So we can see that if this is the rope and we need to find the length of it, it's very simple for us, because now we've got a triangle. See, now look, the question is a hidden triangle. And once we've actually visualized and drawn out what we're trying to work out, we can find out what equation we need to use, what formula we need to use. And here we see we're given two lengths and we have to find out the third length. So we need to use Pythagoras' theorem. So all we have to do is substitute these values into the formula. So once we substitute this into a squared plus b squared equals to c squared, and remember we have to label a, b and c. Let me just circle that into a different color so you can just see clearly. Underline these. So once we've substituted into the equation and we've put it in, so 4.9 squared plus 20 squared equals L squared, and we've reached this part here, so we've rooted it, we get an answer of 20.5915031. Now the question says give your answer to 3 significant figures. So the first thing we need to do, once we've got this, is convert it to 3 significant figures, because this answer will get you the marks, but it won't get you the final mark. So this number to 3 significant figures is actually, so if we do this, so we've got one figure here, 1, 2, 3. If we put a dotted line here, we can see that because this is 9, 5 will become 6. So the answer is 20.6 meters. That's the answer. That is to 3 significant figures. Yeah? So that was our second example. And I think it's much easier. It's a little bit simpler than the first one. But this is just an example of how they can give you a question without already giving you the triangle drawn. So if we just recap what we did in this video, we looked at 2 different types of questions where we have to use Pythagoras' theorem, where it doesn't just give us a triangle straight away. I hope it helped you. Remember, if you have any questions, if you don't understand anything, please leave a comment down below so that I can understand what you guys need help with, and I will add it to my videos, and hopefully that will help you. If you haven't subscribed, hit the subscribe button. Thank you very much for watching.